All right, it's recording, just by the way. We're going to graph linear equalities. Basically, we're graphing inequalities on actual, coordinate planes instead of just number lines like we did in chapter 1. So, linear equality, it's an equation of a line that has an inequality sign instead of an equal sign. And it's an inequality in two variables, meaning x and y, whose graph is a region of the coordinate plane that is bound by a line. So we're not just graphing a line this time, we're going to graph an area. Okay, so we're going to shade, we're going to color. Woo. No? Oh, okay. Here are the steps to graphing linear inequalities. First, we're going to graph the points of the boundary line. Okay, so we're going to graph points. We're not going to connect them yet. We're just going to kind of give ourselves like a skeleton. And then, for step 2, we decide whether the line should be included or not. We base that off of the inequality sign. So if it has a or equal to, that means we include the line and it is solid. If it doesn't have an or equal to, that means it's not included, so we make it dashed. It's kind of like on our number line, the or equal to had a closed in circle, and the not or equal to had an open circle. Okay, it's very similar to that. We actually talked about this when we did that. The part that's added, because we're in 2 dimensions now, okay, we have a whole grid, is the shading. Okay, if you have a less than, it doesn't matter whether it's just less than or equal to, you shade below your line. If it's greater than, you shade above your line. All right, the whole thing up there where it says use a test point, okay, that's only if needed. Only if, you get confused and don't know where to shade. So let's do an example. First, make your axes. Oh, that was so close. That one was good. That one was better. So first we need to just get the points that go with this line. So what's the y-intercept? -3. So we're going to put a point in -3, and based on the slope, how do we move from there? Up 1 over 2. Up 1 over 2. And down 1, left 2. So we have our skeleton. Now for step 2, we need to decide if this line should be solid or dashed. So based on the inequality sign, what should it be? Dashed, because we do not include this line. Too bad you're not using pencil. All right, now step 3 is to shade. Are we going to shave above or below the line based on the sign? Below. So you can see it's easier when they're kind of flat like this that we shade below, but I like to draw those arrows because sometimes it gets confusing. I'll show you. Huh? Yes, I'm recording on purpose. It did not work last period.
Sometimes you record,
Yeah. Now what, does this mean, this graph? The shaded portion means that anything within there, so say that point right there, yeah, 4, -4, that is a solution to this inequality. We could plug in the x and the y, and when you simplify, the left side would be less than the right side. So anything in there would make it true. Anything over here or on the line would not make it true. Okay, so those are not solutions. These are. Yeah, this should be a review. Okay, so let's do the next one. Draw your axes. Oh, check that out. That's pretty good. Nope, not that one. What is our y-intercept? Huh? 12. It's 0. Remember that your intercept comes from what's hanging out the end? It's kind of a funny way to say it, but it is. And there's nothing, so it's 0. Now what is our slope? 3 over 1. So up 3 over 1. Up 3 over 1. Down 3 left 1. We have our skeleton. Should it be dashed or solid? Solid because it says or equal to. That's not very pretty. And then do we shade above or below it? Above. Okay, so take a point on the line and draw your arrow up and it shows you which section to shade. So this one, the entire shaded area and the line give us solutions to that inequality. Don't echo. Don't echo. All right. It's not echoing. Yay! So now we're going to do inequalities, but with absolute values. Okay, so we're going to have our little angle things. So first, let's make, whoa, I forgot I had it on the thick pin. Okay. Our axes. I need to change that. Go medium size. But we need to get the skeleton of our graph first. Now, if you remember, the kind of basic equation is A absolute value x minus h plus k. Where do you want to start? It might help, okay? It might help if we just graph the parent function. Just do it really lightly on your paper if you want to do it at all. But remember, where is the vertex for the parent function? 0, 0. And then, do you know what the slope is for the parent function? 1. It's up 1 over 1, up 1 over 1. So our parent function goes like that, both ways. So how, and the equation for that is y equals absolute value of x. So how is our equation different from that?
It's got a different y-intercept.
We've got a 4
It's
and a
gonna go
5.
right 4 and up 5.
You're right. Right 4. Remember that h is always weird. It's going to be weird all year long. We use h and k all year, and h is always backwards.
Wait, since it's plus, wouldn't it be
Yeah. She said it's
Plus.
Oh, I looked
what
at the
plus?
wrong one. I'm
Sorry.
Apologies.
Oh, it's okay. All right, so we had a minus 4, so that means it moves right 4 and up 5. So I'm going to take that origin, and I'm going to move it right 4 and up 5. So there's my new vertex. D, D, D. I'm going to do it in red. Now from there, we need to check out the A value. A, is it different than the parent function? No, right? It's an invisible 1 right there. So did it stretch or shrink? No. Did it flip upside down? No. So we can follow the basic shape of our parent function, the up 1 over 1, for this one. And we have our skeleton. Now, should it be a solid graph or dashed. It should be solid because it's or equal to. Do we shade above or below it? Below.
So do we shade the whole graph?
We shade the whole graph. So I'm going to pull out the thick marker again. If you'd rather do like just lines instead of shading, that works too. Too much work. Huh. We can make it crossways. Did I ruin it?
Yeah.
Sorry. Right, so that's almost the entire graph. So all these things are solutions to that inequality. Up here, not so much. Any questions? No, remember to look at your A, your H, and your K. Do we know what A, H, and K are over here yet? No. We need to do several steps on this one. Of course, there's always one problem that takes more work than all the others. So this one, we need to isolate Y first. So what should we move? 3, how are we going to do that? Subtracting it. So I get negative Y is greater than 2 absolute value x plus 1 all minus 3. Now what? Divide by negative 1, or we can multiply. Just for the sake of it taking up less room, I'm going to multiply by negative 1. Make sure when you multiply, you're multiplying everything on both sides. So we're actually going to have to distribute the negative 1 on the right side. It'll go to the 2 and to the negative 3. So what happens to the inequality sign? It flips. Why did it flip? Because we multiplied by a negative. So we'll have negative 2 absolute value x plus 1 plus 3. You can't distribute into an absolute value. So just put whatever you feel like is supposed to go in there, just put it in the front. Okay. Whew, step 1 is done.
Wait, if you move a negative, what if you moved a positive? It would stay?
It would stay, yeah. So only when you divide or multiply both sides by a negative is when you flip the inequality sign. All right, step 2 is just like we did on the last one. We're going to find our vertex. The vertex of the parent function is 0, 0. So how did ours move? Up 3 and left 1. I don't know why I started spelling it out all of a sudden. Left 1. So I'm going to make my axes here so I can graph it. Okay, so instead of 0, 0, I'm going to go up 3 and left 1. So there's my vertex. Looking at our equation where y is by itself, is the slope of this one going to be the same as the parent function? No. So you can try to like figure out the whole what the slope should be, but honestly, I find it easiest because sometimes they get really complicated with weird fractions and things. So I find it easiest to just find another point. So we're going to plug in a value for x and find a y. So what would you like to plug in for x? 2. Sorry.
I was going to say -2.
Oh, well that works. Okay, so if we're plugging in positive 2, so it'll be y is less than -2 times absolute value of 2 plus 1 instead of x plus 1, and plus 3 at the end. 2 plus 1 is 3. What's the absolute value of 3?
3.
So negative 2 times 3 is negative 6 plus 3 is negative 3. So we put our 2 in right there, and we got out a negative 3. You don't have to draw those arrows, but if it would help you follow what happened on the notes, then go for it. So 2, negative 3 is a point. How can we get another point from that one? Reflection. So what does the axis of symmetry go through always?
The vertex.
The vertex. So this is our axis of symmetry. We need to reflect this point over to this side. So count how many it takes to get to the axis of symmetry. So 1, 2, 3. Count that again. 1, 2, 3. That is where our point goes. So we see our skeleton. It's upside down this time, right? That's because of the negative. Oh, let me write down that step 4 was reflect over axis of symmetry. We already did it, but we should write it down. Okay, step 5 is just figuring out what our line should be and our shading. So should the line be solid or dashed? Dashed, because it is not or equal to. All right, and then should it be above or below? Which side? Where are we looking for this?
The new one.
The new one, where y is by itself, because that's what we graphed. So it's less than, so we need to go below. So like, to help you think about it, if you need to, just take the dots and put arrows below them, and so you see that we should shade down here. Don't think about it as right and left. Think about it as up and down. Above and below. Right and left will mess you up. Any questions? Yeah.
Instead of finding the other point, could you have not just used where -2 is and the like modified one and just gone over or down to over 1?
Down to everyone? Yes, you can. But the tricky part is when they put numbers in front of the X here, because sometimes that'll happen. Okay, because then it throws everything off. So definitely on those, plug in points. When they don't have something right there, it's okay.
Okay.
Right. So the question was, can we just take that slope and go down 2 over 1? So the answer is yes, unless I have a number in front of the X, because then that throws it off.
So if the slope is 1, 1, it's okay.
Yeah. Okay. Any other questions? No? Okay, you survived the long problem. Now to these down here. We're going to do the opposite of what we just did. Now they give us a graph and we have to write the equation. Would you like to do the line or the absolute value first? Absolute value. Okay. So our last step up above was to do the shading and the line. Like, what does that make the symbol for this? The shading, does that make it greater than or less than?
Less or greater than. Greater than.
It's the, oh, sorry. So on your paper, if you can't see, kind of show that it's shaded down here. And then on the other one, shade if they're part of printing in black and white. So you can't necessarily see all the time. So it's shaded underneath, right? So what does that make our symbol? Less than. All right. And then based on the line, should it be or equal to? Yes, because it's solid. Okay, so we have y is less than or equal to. Now, remember, we're filling in a absolute value x minus h plus k. So we need to fill in a, h, and k. Where do you want to start?
H and K.
H and K. So from the origin, how far did we move over for our vertex?
4.
We went left 4. So what does that make the K?
Plus 4.
Ooh, yes. It's going to be X plus 4 because H is weird. Okay, what about the K?
Negative
3
3.
because we went down 3. So that's going to be minus 3. Now, how do we figure out the A?
Do you see how much it is to go from one point to the next?
Yeah, so from one point to the next, did it change from the parent function?
No.
No, it's still just 1 over 1. So our A value would be an invisible 1 right here. So that's fine. Did it flip upside down?
No.
No, so we can keep it positive, right? So there is your answer. I'm not sure that they gave you any that will have a different A value. I think they may all be 1. All right, so for B, what's the sign going to be over there based on the shading and the line? Greater than or equal to. So if it's dashed, what would be the difference? There would be no or equal to part. All right, so we have y is greater than or equal to. What's the basic structure for a line? Mx plus b. So let's fill in M and B. What do you want to fill in first? Let's go with B. Why not? What's the y-intercept?
5.
Plus 5. All right, so that was there. So how much is it from one point to the next for our slope? Up 2 over 1, so we get a positive 2.
That's not that hard.
No. Now, if you would, go ahead and get the paper out for your homework, and I would like to look at number 3 together. Number 3 on your homework says x is less than or equal to 0. What is this going to look like? Do you know what kind of line it makes when it has x equals a number?
Horizontal.
Ooh, actually, it's vertical. And the y equals a number are the horizontal ones.
I was doing this.
Oh, really? That's funny. Don't know. Okay. So these have undefined slope, and this slope is 0, just for the sake. So on your graph, where will this one's vertical line be? On the y-axis, right? Everywhere on that line, x is 0, right? We haven't moved right or left any? Whoa, except my arrow did. So on there, will it be a dashed line or a solid line? Solid. Okay, and then when it's x, you can't think it is up and down anymore because there is no up and down. It's all right or left. So, where are the x's less than or equal to 0?
On the left.
On the left side. So that is what that one looks like. That should also help you be able to get the equation for number 36 if you want to go ahead and do that one. It's not graphing. They give you the graph and you got to get the equation. All right, homework.